Hi there, another multimeter to review. This one was sent in by VENLAB and it's the VM-600A. I'm not paid for this video, but since I'm allowed to keep the meter, I marked this video as a promotion. From previous reviews, you know that this doesn't stop me from sharing all my findings with you. In the box we find probe leads, 4 AAA batteries, a K-type thermocouple, somewhat unusual, 2 spare fuses, the meter of course, and a manual. In its shape and color theme, the meter reminds me of the HT118A I reviewed a while ago. Max 20 amps, which is more than many 1000 volts Cat 2 and 600 volts Cat 3 is impressive, if it's true. It has a bluish plastic protection sleeve, some strong magnets at the rear. They easily support the meter hanging on a steel rack door. On the top is the protruding antenna for the NCV function and an LED for a torchlight. The battery compartment is opened with a single screw that goes into a metal thread insert. The door with a lifting bail lifts out. Initially I assumed it uses 2 AAAs and we got a spare pair, but not so. It needs all 4 AAAs. Okay, let's put them all in and see if it works. I always do that before taking it apart, because then I know if it doesn't work anymore afterwards, I must have broken it. It turns on and the display uses large, easy to read numbers. Time to look inside. It is relatively easy to get it out of the protective sleeve. The sleeve is rather thin, not offering much protection against serious mishaps. The tilting bail relies on the sleeve to hold it closed. Without it, the thing just flaps loosely. Speeding things up, the back shell is held by 4 screws at each corner. As expected, these are self-tappers. It comes apart easily. No shielding in the back shell, just the battery contact springs that touch the PCB when the meter is assembled. Not a bad way to solve this problem. A closer look at the PCB. First impression, why is there so much empty space at the bottom below the sockets? This meter could have been quite a bit shorter. Maybe it has something to do with those puny class fuses for 20 amps 250 volts and 600 milliamps 250 volts, which are not supporting the Cat rating on the outside. There might be a different version of this meter which uses the extra space in the enclosure to add the protection and large fuses needed for that, but this model is certainly pretty basic. The 600 milliamp fuse has no brand name or certifications. It is labeled F0.6A L250 volts. The F means it's a fast acting one. The L means it has low current breaking capability. VENLAB provides 2 spare fuses of this type in the box. The 20 amp fuse also has no branding or certifications. It is labeled F20A L250V. Another fast-acting fuse with low breaking capability. What does low breaking mean? I looked at some datasheets of fuses and it seems to be 10 to 30 times the rated current. For the 600 milliamp fuse, which is the most likely to blow, hence the spares, this would be 6 to 30 amps. Even just a Cat 1 environment can exceed that easily momentarily, never mind higher Cat 2 ratings. For comparison, this big one is the 440 milliamp fuse for my Brymen 869S. It is rated for 1000 volts and to break 10,000 amps safely. Or these bunch of 0.5 amp fuses rated at 440 volts capable of breaking 35,000 amps. Those puny class fuses will simply explode. Hopefully the meter will be able to contain it. Apart from the small fuses, there are 2 PTCs and a couple of diodes, and that's it as far as protection goes. This is on par with the HT118A and many other budget meters, but the HT118A has at least some unlabeled but hopefully high rupture sand-filled ceramic fuses. Other than that, we have the blob as the brain of the VM-600A and an EEPROM next to a location where a connector can be placed to program it. There are no trim pods or similar adjustable components. This meter is calibrated in the factory with the data stored in the EEPROM. Obviously, someone in the same factory was very generous with the grease for the axis of the rotary range switch. It has oozed out onto the PCB and half covered one of the contacts of the battery springs. The contact obviously still works, and the indentation shows that these springs really put pressure on the PCB. The extra grease on the top is nothing compared to what's going on here on the underside. The tracks of the range switch are covered in grease. I don't think I've ever seen so much in a meter. It even covers the current shunt. Imagine passing 20 amps through that. I fully expect unpleasant smells and maybe smoke coming out of the meter when this shunt gets really hot. Apart from the current shunt, there are no components on the underside of the PCB. I put it back together to look at battery life. In normal operation, the current consumption is not too bad, around 1 mA, varying between 0.8 and just under 2 mA for most modes. Turning the backlight on increases that to around 25 mA. In VENLAB's defense, it's very bright, but maybe less bright would have worked too. Turning the torch on and now it's 85 mA. And actually, for that I find the torch not all that bright. The notable exception to the moderate 1 to 2 mA is continuity and NCV, because both are using the beeper and the multicolor LED on top. The current shoots up to 64 mA. Most of this increase is due to the beeper, because if the resistance is more than 40 ohms, as in this case, continuity doesn't beep and only the LED is turned on in red. In that mode, current is only about 13.5 mA. For the highest consumption, here is NCV while using the backlight and the torch. The O1 is in max min mode, which shows that the current jumped from 1.06 mA minimum to more than 131 mA maximum, which is quite staggering. The lowest consumption occurs if you forget to turn the meter completely off on the range switch. After 15 minutes of no interaction, it turns itself off. Once that happens, it draws around 162 microamps, which is only around 7 times less than its normal current when on. It's definitely a good idea to turn the meter completely off instead. With 4 AAAs, the nominal battery voltage is of course 6 volts. It proved rather difficult to establish the point when the low bat symbol appears because the meter is way more sensitive than I expected. Dropping below 5.55 volts brings it on. That is a terrible choice because it means bad battery life with normal batteries, and it rules out using rechargeable batteries. Just briefly, here are 2 AAA batteries. The left one is non-rechargeable alkaline, the right one a rechargeable type. They happen to be energizers, but that's only because they make their datasheets easier to find. Other batteries are of course available. It should also be obvious that the discharge curves in the datasheet are for much higher current, but they are similar for lower currents, just the numbers at the bottom are 5 to 100 times of what is shown here. 5.5 volts for a low bat warning means it's just below 1.4 volts per battery. While alkaline starts with 1.5 volts or even slightly higher, in use they continually drop until they reach end of life at 0.8 volts. The voltage will drop below 1.4 volts very quickly, probably with less than 20% of the battery capacity used. For rechargeables, the problem is that freshly recharged, they start around 1.4 volts, but then drop quickly to between 1.3 and 1.2 volts and stay at that voltage for most of their charge. Only at the very end does the voltage drop very steeply. In the VM-600A, this means for alkaline batteries, the low bat symbol will appear when the batteries are nowhere near low, and for rechargeable, the low bat symbol appears right away even with freshly recharged batteries. I reported the problem to VENLAB, and to their credit, they did investigate the problem, and this is what they said. The threshold of early VM-600A is 4.8 volts, but some customers accidentally installed the battery upside down when using it, which caused damage to the multimeter. To solve this problem, we added a diode in the power supply end, which would cause a voltage drop, so we changed the threshold to 5.5 volts, and there was no complaint about burning the meter after the reverse battery was installed. The diode is this one here, an M7 equivalent to the well-known 1N4007, losing around 0.6 volt when the batteries are the right way round. A Schottky diode with less drop may have been a better choice. The reduced battery voltage gets to this low dropout regulator of the 6209 family, which produces 3.3 volts for the actual meter circuitry. The regulator dropout is specified as 80 millivolts, so it needs at least 3.38 volts input to produce 3.3 volts output. But let's be generous and just say 4 volts input would be plenty of running the meter. I think the threshold should have been lowered, for example to 4.2 volts instead of raised, but that's what happened, and while it's good that the meter now survives wrong battery polarity, this fix comes at a rather high usability price. What happens if you keep using the batteries even after a low bat symbol appears? I tested this with a few sample measurements. This is DC volts. The reading on the VM-600A is a bit blurry, but it's clear that nothing happens until the voltage drops below 3 volts. This is great. It means you can ignore low battery and keep using your meter, which is why this video shows the meter mostly with a low bat symbol on. The only trouble is you never quite know when your meter is going to shut off completely because it finally ran out of juice. If you have a second meter, you can easily check the battery voltage of the VM-600A. Never try using a meter to measure its own battery voltage. Nearly all meters, cheap or expensive, have the battery terminals on a different potential than the probes. This means in touching the battery with the probes, you would short circuit part of the electronics inside and likely destroy your meter. Even expensive flukes have been killed that way. Using a separate meter shows that these rechargeables are still nearly full but already below the low bat threshold. Another way to keep track of the state of your VM-600A batteries is to use one of these cheap testers occasionally. The probes are rated for Cat3 600 volts and 20 amps, at least that's what they say. There are no markings on the very stiff leads. The VM-600A has no warning, audible or light that tells you that the leads are in the wrong socket. Leaving the red lead in the milliamp or 20 amp socket while selecting and measuring volts is a common mistake, and if you are very lucky, only the fuse will blow. The K-type thermocouple ends in 2 standard banana plugs. Not much else to say about it. The viewing angle of the LCD is fine. Keep in mind that I left a protective foil on the display. One-handed operation is no problem when the meter is lying on the bench. No sliding around when rotating the range switch. And the same is true when it's on its tilting bail. Steady as a rock, very nice. As I mentioned, the backlight is nice and bright. It turns itself off automatically after 30 seconds. The same timeout also applies to the torch, whether you need it or not. Since the torch light is not in the center, I tested it with a probe in the right and left holder. I think the left holder is probably better for this. The meter turns itself off after 15 minutes, but you can disable this by holding the funk key when turning the meter on. It does 5 beeps to tell you that automatic power off is now disabled. Yet it still beeps a warning that it's about to turn itself off after about 14.5 minutes, and about a minute later you get your last warning of another 5 beeps. Normally the meter would now turn itself off, but of course in this case it doesn't. Despite that APO is disabled, this highly annoying beeping ritual repeats every 15 minutes. It's apparently baked into the chipset because the VM-600A is far from the only meter with that feature. A quick tour of the boring bits, accuracy and all that. This is DC and AC volts. The green line indicates the allowed tolerance according to the specs, which are included here. The VM-600A has no problems in meeting its spec comfortably. It struggles at the very low voltages, but that is to be expected and more a result of its limited resolution. The same 1 millivolt difference is just 0.1% at 1 volts but 10% at 10 millivolts. Note the change spec on the AC voltage. The red text is what's printed in my manual. The fact that the 750 volts is more accurate than the lower ranges is odd and, as it turns out, a mistake. There are a number of such things in the printed manual, and when I mentioned it to VENLAB, they sent me the latest electronic copy which fixes them. The DC and AC currents is very similar to the volts. The VM-600A meets its spec easily, although I did not test it to the full 20 amps. It is generally much better than the stated figures. We have again a printing error in the manual that came with the meter, and the corrected number in the electronic version is much tighter but still achieved by the VM-600A. The bandwidth is as stated in the manual. The -3 dB point is almost exactly at 3000 Hz. I did not verify the claimed input impedance, but meeting that within the stated bandwidth is usually not a problem. Frequency measurements are spot on for the whole range, but of course limited in a resolution of 4 digits. It goes exactly up to 20 MHz and not any further. You can toggle the frequency measurement to a duty cycle measurement mode, which really only makes sense for rectangular waveforms, and in my tests this worked fine and accurately. At the lowest 600 ohm range, resistance measurement has only 0.1 ohm resolution, so below 10 ohms the high error percent values and wild deviations are simply a result of the low resolution. The problem is less apparent the higher the ohm value. The enlarged graph from 10 ohms to 100 meg shows it's pretty accurate and well within its spec until 30 meg ohm or so, when the error is creeping above the 1.2%. The problem in verifying accuracy for capacity measurements is that I only have a few 1% capacitors, not enough for a whole range spanning 7 decades. So what I do is that I compare the VM-600A readings of the same capacitor after measuring with a meter with better specs, in this case the Fluke 187. The Fluke has its own error rating in capacitance mode, which I show as red bars. You need to keep in mind that this means that for the true accuracy the Fluke's tolerance needs to be added, but in either case the VM-600A will meet its specs. And finally, temperature. I did this by applying the equivalent voltages based on the NIST tables for K-type thermocouples. However, one needs to compensate for the applied voltage for ambient temperature. One of these days I may make a video about this method. For now, there is no issue with the VM-600A, and any errors you see in real measurements will be caused by the thermocouple, not the meter. Interestingly, the meter slightly exceeds its specs in that it can handle -40 degrees Celsius to +1300 degrees Celsius, that is -40 degrees Fahrenheit to +2372 Fahrenheit. The VM-600A shows the diode forward voltage, or OL for reverse, but there's no beep for either direction, so you have to look at the display to find out. 2 diodes in series are no problem. I'm displaying the forward voltage of a single red LED. But not 2 red LEDs in series, at least they both still light up very dimly. Forward voltage of 1.9 volts for one yellow LED works fine, and the 2.6 volts of one white LED. My go-to meter for NCV is the Bryman BM235. In high sensitivity mode it can detect from quite a distance that the power in that black cable has been turned on. If I replace it with a VM-600A at the same position and turn the power back on, nothing. Moving it closer and closer, the antenna is actually touching the cable, and finally it tells me there's power here. The VM-600A NCV works, but it's very insensitive. Actually, there are cases that this can be good, for example in a very polluted environment with lots of powered cables. For exactly that reason the BM235 has also a low sensitivity mode. If only one sensitivity is available, as here, I would rather want the meter to be more sensitive. In continuity mode, the VM-600A beeps and lights a green light for resistances up to 40 ohm. For 40 ohms and above, the beep stops and the light turns red. For 60 ohms and above, there is neither beep or light. That box with the chicken head knobs, by the way, is an interesting eBay find. I made a video about it and link it here if you are interested. The standard continuity response test using the provided probes is pretty bad and inconsistent. But I think this is more a problem of the probes than the meter. Let's see if cleaning the tips with some isopropanol improves the performance. With clean probes, the meter is quite a bit more responsive compared to before, but still nothing to write home about. I replaced the original probes with these from Pomona. Other brands are available. Now that's much better, and the conclusion is, as with most budget meters, replace the probes and get some better ones. It's a worthwhile improvement, not just for continuity. Maybe some eagle-eyed viewer was already wondering about this button. It selects frequency or duty cycle, that much is clear, but the last thing clearly looks like a delta. Is this a rel function? But pressing it has no effect in nulling the 0.5 ohms displayed in this test in resistance mode. Rel does work, but only in capacitance mode, to null the stray capacitance of the measurement leads. To be fair, later I found in the manual that this button is explicitly labeled frequency/duty cycle/capacitance 0. Its use is never mentioned under capacitance measurements or anywhere else in the manual. The VM-600A exhibits exactly the same problem as the HT118A when exposed to mixed AC-DC signals. The red meter shows the DC on the main display and the AC above. For the VM-600A, I have to toggle between them. With 17 volts DC mixed with 83 volts AC, there's no problem. But changing to 68 volts DC with 51 volts AC and the VM-600A auto-ranging gets in an endless loop. It can be rescued easily enough, but in some cases the effects are not as clear and totally wrong readouts are possible, like in this case where the VM-600A shows an AC voltage of 4.1 volts when it's really nearly 51 volts. The VM-600A is not alone in having trouble with mixed AC-DC, and you should really be very cautious with most meters in believing the display when measuring such signals. To wrap up, what's my verdict on the VM-600A? First of all, I want to thank VENLAB for sending it in. Every multimeter, whether it's a budget one or a really expensive one, has its own strengths, weaknesses and quirks, and the VM-600A is no exception. The biggest quirk for me is the low battery warning that comes ridiculously early. I wonder how many still perfectly good batteries are thrown away because of this. If you do normal measurements, the VM-600A is actually quite efficient and taxes the batteries very moderately. But as soon as beeps or lights are called for, the power efficiency is gone, and in the interest of battery life, you should minimize those instances. There are no warnings if the leads are left in the amp or milliamp sockets and a non-current range is selected. In a sense, this is how it used to be, certainly for low-end budget meters, but times have moved on and one would hope modern meters would do a little more to help beginners to prevent this common mistake. To provide 2 spare fuses is an interesting approach, but prevention would be better than spare fuses. More so, as the fuses themselves are very cheap. Probing main circuitry with these fuses is very risky. You should definitely replace both with high breaking capable fuses from reputable manufacturers. Usually those fuses are ceramic and sand filled, but the size of the fuse holders will limit what can be done. The input protection against transients is too basic, and I would not believe any of the CAT rating stuff that's printed on the meter and the manual. Use this meter only for electronics and at best for CAT 1 250 volts after upgrading the fuses. Like all budget meters I tested, the provided test leads are disappointing. The tips struggle to make contact and the cables are stiff and unpleasant. The meter can be much improved if you replace the test leads with decent ones. Also disappointing in my book is the sensitivity of the NCV mode despite the antenna sticking out so prominently. The other modes work as promised and the selection of modes and ranges is quite good, suitable for electronics work. The accuracy is generally better than the spec and in line with what you expect from a meter in this class. Like a lot of meters, including some more expensive ones, the VM-600A has sometimes trouble making sense of mixed AC+DC signals, especially if the AC and DC components fall into different range brackets. It is something you need to be aware of and be extra careful when suspecting such conditions. The general build is good, the meter body is larger than it needs to be, but the display is good and easy to read from most angles and it can be operated easily with one hand when lying on the bench or on the tilting pail. The magnet at the back can be useful in an industrial setting, but for normal toolboxes it may prove a nuisance picking up screws and sticking to tools. And there you have it. The VM-600A is a typical budget meter and has the class typical quirks and annoyances, but there are some redeeming qualities too. The main issue I have with it are with the fuses and the minimum input protection. If you are planning to use the meter just for electronics works, it's fine, but I would not recommend using it for serious electrical work. If you like my videos, don't forget to subscribe, and if you have not already, maybe consider becoming a Patron. That would really help this channel. The link is in the description. As a patron, you always get early access to videos, a blog and other exclusive content. Thanks for watching.